Welcome to radical operations. So we're going to be working with a variety of different math operations you can do with square roots. So we're going to use square roots throughout this unit in different ways. So in this first section, what we're looking to do is simplify a radical expression. And by that we mean break it down as far as you can with perfect squares that can come out of things. So if we look at the number 125, we could create a factor tree, and we could say that that breaks down into 5 times 25. So I know it was divisible by 5. I could pop that in my calculator, and $1.25 divided into 5 would be 5 quarters. So I get that, and I know 25 is 5 times 5. So whenever I break something down in these factor trees, I always like to cross it out to make sure I know I got rid of it. And this 25 I broke down, so I crossed that out, leaving me with a 5, and a 5. Now, getting back to my original problem, I see that I'm taking square roots. And so what I'm going to look for is pairs of squares. 5 times 5, remember these are all times each other. 5 times 5 would be 5 squared. And then times another 5. And I have my square root around all of it. So if I'm creating equivalent operations, square root of 125 is equal to the square root of 5 squared times 1 extra 5. That breaks down into, I can split the root, square root of 5 squared times square root of 5. Now the place this becomes useful is the square root is the undoing of a square. In the same way that if I were to multiply something times 10 and then divide it by 10 right away, that would undo that operation and you'd get back to where you started. If I take the number 5 and square it to get 25, and then I square root it, I get right back to 5. So essentially, every time I have a square of a square root, I get back to my original number, but with no root anymore. So my final answer for this problem is going to be 5 times the square root of 5. And when you write it like that, you don't need the times symbol. So 5 root 5 is how that's usually pronounced. Let's jump over to another example. Square root of 108 x cubed. So now we see x's in the problem. So when we take our 108, we can do that same factor tree we did before. And I don't really know what 108 is divisible by, but I know it's even, so I can divide it by 2. So if I do that in my calculator in my head, I get 54 and 2. Cross out the 108. 54 is also even, so again, I don't really know what that's divisible by, so I divide it by 2, and I end up with 27. Take that number, and I know 27 is divisible by 3. I know it's 9 times 3. Cross that out, and then 9 is 3 times 3. So when I look at this, again, we talked about looking for pairs, because a pair of something is something times itself, something squared. So here I have a 2 and a 2, making a 2 squared. I have a 3 and a 3, making a 3 squared, and then I have this extra 3 right here. Now, I don't want to forget about my x's either, so let's go ahead and do those. X cubed is just x times x times x. We remember breaking some of those down earlier. And I do the same thing. I look for pairs. So I have a pair there, and then I have a leftover x. You can choose how you graphically organize this. I like to do a bubble around my pairs and then a square around my leftovers, so that's all up to you. Then I need to rewrite what I have. So I have the square root of 2 squared, that's this, 3 squared, that's this, x squared, that's these, and then times 3 times x. And I like to keep track of things carefully because otherwise you tend to lose things in big problems like this. Everything that is a nice clean root, I can go ahead and take out. So 2 squared square rooted is just going to be 2. 3 squared square rooted is just going to be 3. X squared square rooted is just going to be x. So I have 2 times 3 times x all out front. And then left behind in the root, I have 3 times x. Cleaning it up, 2 times 3 is 6. 6 times x is just 6x. Square root of 3x. So this would be my simplified answer. The idea is to break it down as far as you can. this example throws something a little bit new at us because we are asked to deal with that whole number already out in front. So if I look at my 18, it's under a root, and I'm going to break it down. I know that 18 is 2 times 9, and 9 is 3 times 3. Broke down the 18, I broke down the 9. I look for my pairs. I have a pair of 3's, and then I just have a leftover 2. So I am going to rewrite my original problem, and I'm going to be careful not to lose the 3 that I started with. So I'm going to put that out front, right where it was before. And then in the root, I have my 3 squared and my times 2. When I go to my next step, I know that I can take out that 3 squared because it is square root of a square, so it just comes into a 3. But I can't lose this 3 that I had originally. So I have the original 3 that I started with, and I have to multiply it by the 3 from the inside here. So that's where that one came from. And then I still have my square root 2. So my final answer is actually 9 square root of 2. It's because I had a 3 out front and a 3 squared from the inside that came out. Finally, let's try one crazy example here that brings it all together. So when we look at this problem, we have a number out front, a square root, we have letters, we have numbers, big numbers. So let's start in the root and start breaking things down. 200, well, I know that it's 2 times 100, and I know 100 is 2 times 50. 50 is 2 times 25, and 25 is 5 times 5. So I broke that down, that down, that down, that down. And when I look for my pairings, I see a 2 squared, a 5 squared, and a leftover 2. I have my x times x times x, so again an x squared and a leftover x. I have y times y times y times y, there's 4 of those. So a pair of y's, another pair of y's. And then I just have a z by itself. The z is to the 1 power, so that's just a leftover z. So let's bring this all together. I have my negative 9 out front that I started with. Can't lose that. Square root of 2 squared, 5 squared, x squared, y squared, another y squared, and then I have 2 times 2 times x times z. You have to be careful with your handwriting. If you're anything like me, that 2 and that z look dangerously similar to each other, so be careful with that. So as we work through this, I know that everything that is a perfect square under the square root can come free. So I'm going to write those out front as negative 9 times 2 times 5 times x times y times y, 2, 5, x, y, y, and I had my negative 9 originally. Then I have my square root and my leftovers, 2 times x times z, 2x and z. Multiplying my numbers out front, I have 2 times 5 is 10, and 10 times negative 9 is negative 90. Do that in the order that makes it fastest. So doing 2 times 5 first makes it a little quicker to do that in your head. I have an x, and y times y is y squared. My leftovers then, 2x z. So try to make your z's and 2's distinguishable. Good luck.